Hello students, how is your day going? Today we'll be learning with chapter 8.1, Work and Power. So with this we start with doing work. Net given to energy transferred by a force is known as work. Examples of forces doing work are pushing a trolley to start it moving. Pushing force does work and transfers kinetic energy to the trolley to keep it moving. B. An apple falling from a tree. Gravity pulls the apple downward. Gravity does work and the apple's kinetic energy increases. C. Braking to stop a bicycle. The brakes causes friction, which does work to reduce the bicycle's kinetic energy. So, with that, let's deal with this activity to fill in the missing words. To lift an object, you need a store of energy. You give the object more gravitational potential energy. The force is your means of transferring energy from you to the object. So let's check. That's correct. How much work? The amount of energy transferred by an object depends on two things. A. The size of the force. B. The distance moved in the direction of the force. What is illustrated below? Looking at the two diagrams, we have the women using a thread wrapped around the load to be pulling it. From the second diagram, the load has what? Moved up due to the what? Presence of contact force. We have to fill in the missing words to serve as an activity for this page. Lifting an object requires an upward force pulling against gravity. As the box rises upwards, the force also moves upwards. Energy is being transferred by the force to the box. Let's check. That's correct. So let's move on. Calculating work done. Work done by a force is equal to the product of the force and the distance moved by the force in the direction of the force. W is represented in work, F representing force, D representing distance. Work is measured in joules. The product of force and distance also is measured in joules. The equation of work done above shows the relationship between joules and Newton. That typically shows that 1 joule is equal to 1 Newton meter. So with this true or false statement, let's check it out. 1 joule of energy is equal to 1 Newton meter. Is that true or false? The answer is true. So let's check. That's correct. Now let's deal with this calculation. A crane lifts a crate upwards through a height of 20 meters. The lifting force provided by the crane is 5 kilonewton. How much energy is transferred to the crate? Now, this is what happens. H is 20 meters. Force is equivalent to 5.0 kilonewton. Don't forget that wherever you have 1000 newtons is equal to what? 1 kilonewton. So force now what? 5 times 1000 newton, and that is what? 5000 newtons. And the distance or h we is given is what? 20 meters. So I can then say that energy, just like work, is force times distance, and that gives 5000 multiplied by 20, all in what? In joules. So you now have 5 times 2 is 10. How many zeros left? We have 4 zeros. Joule. Don't forget that you have 1000 joule to be what? 1 kilojoule. So what will be 100,000 joule? That will be what? 1 over 1000 times 100,000. That's kilojoule now. So this cancels this. So our answer now is what? 100 kilojoule. Let's pick the answer and see. That is correct. Okay. Now let's deal with this question 2. Work done and the gravitational potential energy represented with what? NGH. Looking at this diagram, it has the load has a weight of 400 newton. It is being pushed with a force of 200 newton over an inclined distance of 2.5 meters, while the height of the structure of support is 0.75 meters. With that, let's read the question and answer the questions appropriately. A girl can provide a pushing force of 200 newton to move a box weighing 400 newtons onto a platform. She uses a plank as a ramp, as shown in the diagram. How much work does she do in raising the box? How much gravitational potential energy does the box gain? So this is what will happen. The force that is used for push, that is, we can call it F, subscript P, is 200 Newton. And with that, we already know that work that will be done is what? Force times distance. Don't forget that she's pushing through a distance of 2.5. That will be W is equal to F, which is 200, multiplied by what? 2.5. I can write 2.5 in proper fraction. That will be 5 over 2. All in what? Joules. Okay? And that gives me 2 here 1, 2 here 100. 100 times 5, that's 500 joules. That is the what? The work done by the what? Girl. Now, let's deal with the second question. How much gravitational potential energy does the box gain? We are dealing with W now. Is equals to what? Mg times what? Height. And that's the force required times height. With that, we have 400 newtons times the height now is 0.75 meters. I can write 0.75 meters in fraction. That will be 3 over 4. All in what? Joules. Fire 1, fire 100, and that gives me what? 300 joules. So with this, I have the girl does 500 joules of work, but only 300 joules is transferred to the what? Box. So let's pick it and see that is correct. Alright? Now, in what unit do we measure the work done by a force? Just like you've seen before, the work done by a force is denoted as what? Joule, or you can write it in terms of Newton meter, but joule will be appropriate. Let's click and see. That's correct. So 1 joule is equal to 1 Newton meter, but the appropriate is what? Joules. How much work is done by a force of 1 Newton moving through 1.0 meters? So let's calculate and check the answer. So I have how much work? So work is what? Force times distance. I have force of 1 Newton multiplied by distance of what? 1 meter. Don't forget that Newton meter is joule. 1 times 1 is 1. I have 1.0 joules. Okay? I have 1.0 joules. So that is it. So let's pick our answer and check. That's correct. So looking at this question, under work and gravitational potential energy, the diagram above shows the cyclist riding along a hilly road. At which position does the cyclist have the least gravitational potential energy? Now, to have the highest gravitational potential energy, that will be at B. But to have the least gravitational potential energy, that will be at A. That is due to the what? Height. But here now we have the highest gravitational potential energy. So that is at what? B. Let's pick B and check. That is correct. Now, let's choose the correct statement before we call it a day. In a specific system, the amount of energy transferred is equal to the amount of power used. Is that statement right? Okay. I don't think so. It's not right. Because energy can neither be created nor destroyed, but can be converted from one form to another. Let's check the second statement. In a specific system, the amount of energy transferred is equal to the amount of what? Work done. That statement is what? Correct. Because energy is equivalent to work done. They are both measured in joules or what? Newton meter. In a specific system, the amount of efficiency transferred is equal to the amount of work done. Efficiency and work done are not typically related, so the statement is false. The second statement is correct. So we pick that, and as you can see, that's correct. With this, we've come to the end of this class. Do well to subscribe to our channel and website www.edubbey.com for more of our interactive books, interactive notes, course representation, and our interactive videos. Do have a great time. Bye.